All right, handout 3.1, descriptive statistics. Okay, now remember the definition of statistics, right? Statistics is just facts or characteristics about a population or a sample, right? The analogy that I like to use is imagine if somebody asks you what kind of car do you own, right? There are essentially infinite number of ways you can answer that question. You can tell them the model, you can tell them how many horsepower, what type of engine, you can tell them the color, or you can even draw them a picture, right? Or show them a picture, right? And all these different ways of answering that question, right? And it's about describing something in reality, right? There you have a car that is the reality, that is the real object. Right? And here, for example, right, we have a set of data. This is the cost of filling up, right? And this is a sample data set, right? And all right, so this is something that exists in reality that is real. Now we want to be able to describe this, or analyze this. Now this is not summarized. This is raw data, so it's not very useful. Right? There's too much information here. So then we summarize it, and so we did this in chapter 2. We can put it in terms of a frequency distribution, and once we have that, then we can draw a histogram. And once you have a histogram, we can abstract information very quickly. So for example, we can see that on average, the fill up cost is between $34 and $46. Okay. Now, chapter 2 is all about using graphical representation to describe a set of distribution, or a set of data to describe the distribution. In chapter 3, we will use numerical measures. Right? We will use numbers. Now, quick reminder, right? A sample is simply a subset of the population. Right? Now, from now on, right, whenever we say statistics, we will be emphasizing on sample statistics. Now, there is population statistics, such as population average, population variance, and so on. Right? Now, because those, right, are going to be the ones that we like to estimate. Because remember, in practice, we never have the entire data set for the population, right? We never know these populations. So we like to estimate them, okay? So basically, for the rest of statistics, we are going to use sample statistics to try to estimate population parameters, okay? So from now on, population statistics will just simply be called population parameters. Okay? Why are they parameters? Because they define where the data comes from. Right? Okay, we'll have a chance to talk more about the theoretical idea of what a parameter is. Right? But for now, just know that now population parameters just means population statistics. And here, right, sample statistics will be referred to as the point estimate for the population parameter. For example, x bar, it is the sample mean. Right? Then this will be an estimator for the population statistic, or the population, right, population mean. Right? Measure of location. So this is the first numerical measure we're going to have, right, to describe to describe data. Okay. Now, the more commonly, so here are the 7 ones that we're going to talk about. The most commonly ones are mean, median, mode, percentile, and quartile. Okay, let's get started. So mean. Mean is also known as average, okay, and this is the average that you've known since elementary school. Okay, if you look at the formula, it's simply adding up all the values and divided by how many values there were. Right. Now, we will have sample mean and population mean. Okay, so remember this notation. We call this x bar. Right. X bar. X bar is simply the sample mean. Now, any population parameter, right, in statistics, we will use Greek letters. So that makes it very convenient. Anytime you see a Greek letter, it is a population parameter. Right? That is the object that we are trying to estimate. Okay. Oh, so this is pronounced mu. That's the Greek letter mu. and that is the population mean or population average. By the way, most of the time we're going to interchangeably use the word mean and average. Okay, all right. All right. And whenever we talk about between sample and population, little n here, this is going to be the sample size. How many data point or observations you have in your sample, and big N is going to be the population size. Population size. Okay. Next, median. Median is basically just means the middle value, right, of your data set. Okay. Now, median is actually a little bit more difficult to calculate because the data must be in ascending order first. With mean, you do not need the data does not need to be in ascending order, right? You can, if you have a set of data, you can simply add it up. Right? With a median, you need to put the data in ascending order first. Secondly, right, you have different procedures depending on if it's an odd number of observations or even number of observation. Okay, let's do an example for odd first. Right? So now here I have 1, 2, 3, 4, 5, 6, 7. So I have n equals 7. I have a sample size of 7, and I want to find the median. I will rearrange this first in ascending order. Next, I simply find the middle one. Now, one quick way you can do this is you just simply take n divided by 2, and in this case is 7/2, which is 3.5. Now, the fact that it is 0.5 tells you that the sample size is odd, and you simply round up. So you just let it go 4. So you always just round up, right? And then you can see then 1, 2, 3, 4. The median is in the 4th position. Okay, and you can see that by isolating this position here, you divide the data set in half. So you have three positions on each side. So that in the middle here, that is the median. So the median in this case equals 4. Okay, all right. Let's try this here. This should be. Oh, I filled it in. 53. Okay, so now I have a data set here. 1, 2, 3, 4, 5, 6, n equals 6. Now I have an even number of observations. Okay, that means I can divide the data set evenly into 2. Right, 3 on each side. Okay, just double check. N divided by 2 is 6 over 2 equals 3. So I can divide 3 on each side. All right, so I don't number in the middle, but I need a median. So what do? I take the average of the two middle values. So you take the average of 36 and 41. So the median here equals 36 plus 41 divided by 2, which gives you 38.5. Now, one quick word, right? And this illustrates why both of them are important. Now, so the mean or average is more commonly used, right? And and this is what they teach you in elementary school, and when people, generally speaking, when they say average, right, they're talking about mean. Okay. However, if the distribution is skewed, meaning that if there exists extreme value, right, in the data set, right, then the median is typically a better measure because it is not affected by extreme value, unlike the mean. I'll give you a simple example. Right? Suppose I have 1, 2, 3, 4, 5, 6, 7. I have 7 positions here. Okay, I have 7 numbers. All right, and let's say I have all these numbers 2, 2, 2, 2, 2, 2. Okay, a very extremely simple data set. The mean is going to be 2, meaning the average is 2. The median is also 2. Here is the median. Right, median is also 2. Okay, and you can imagine, think income. Right, imagine if everybody have the same income. Right. Now, however, let's say that this number is not 2 anymore, and instead it is 50. Okay? Now, what is the median? The median is unchanged. The median is still 2. Right? Median is still 2. However, what is the new mean? Right? The mean is going to be a lot higher. Okay, and the higher this is, let's suppose that this goal is 500 instead, right? The mean is going to get pulled up a lot. Right? Now, in generally speaking, whenever we say the average income, in our mind we're thinking about the average guy, right? The median, the average guy you meet on the street. Well, if there is a high income inequality, right, for example, right, then the average, right, is not going to be representative of what most people make. Okay? But however, median, because median is unaffected by these extreme values, so in certain circumstances, right, a median is a better measure of center. Mode is very simple. This is just the value that occur with the greatest frequency. All right. So if a data set has one mode, we call it unimodal. Two modes, call it bimodal. Three modes or more, we call it multimodal. Okay. Now, for example, right, here is a stem and leaf plot. So let's go ahead and practice how to find the median and how to find the mode. Now, the first step you want to do with a data set like this is, well, count how many data set or how many observations there is. Okay. One good way to count this is to count how many are in each row. Okay. Add it all up, you get 50. Now, so I know that n equals 50. Okay. Then to find my median, remember my n divided by 2 gonna equal 25. Right? This is an even number, right? And that means I can cut this data set exactly in half. So now all I gotta do is find the 25th position. So my median will be the average of the 25th position and the 25th plus 26th position divided by 2. So you just want to find those two. Feel free to pause to take a look first. All right. If you just simply count down 1, 2, 3, 4, 5, and so on, count all the way over, what you will see is it is the 25th and the 26th position. It is these two numbers. Okay, so that is 75 plus 76, and you divide it by 2. That will give you your median. That is 75.5. Okay, so that's your median. What about the mode? The mode is the most frequent one. All right, trick here, you just look at the longest repeating number, right? And in this case, you can pause it again. Pause if you want to try it on your own. But here we can see this 2, 2, 2, 2. That is the longest repeating number. Right? Everything else, for example, here we have 999. There's only 3. 777. That is only 3. 2, 2, 2, 2. This is 62 repeated 4 times, and that occurs more than any other number. So my mode equals 62. Skewness. So skewness is going to be a word that we're going to use to describe the shape of the distribution. Let's start with the middle one. Right? When there's no skewness, meaning when the center here, which if it's peaks right at the middle, that means the mean and the median and the mode are at the same place in the same number, right? And the tail, right, are exactly the same. We call this symmetric. So there is no skew. Now, let's suppose that we started here, but then now the graph turned this way. Okay, what is happening? There are extreme values on the left. Right? The way to see this, the best way to look at this is if you cover this up, this will be symmetric. However, because there are extreme values on the left here, like this graph is being pulled to the left. That's why we call this skew left. It takes a little while to get used to because all the data is here, so intuitively, right, it is common to want to call this skew right, but no, because we were focusing on where the extreme values are, and here the extreme values are very small, right? So the graph is being pulled to the left, so we call skew left. Vice versa, here the extreme values are to the right. The extreme values are large, right? And so the data set is being pulled by these high extreme values. So we call this skew left. Skew right. skew right. Now, the mode is going to be at the peak, so therefore the mode will be here as well. Now remember our exercise or practice earlier, right? The mean and median, okay? The biggest difference between them is that the mean is affected by extreme value. Therefore, if I just draw two random arrows, right? Then to think about which one is the mean or the median, you just have to see is which direction is it being pulled. The data is being pulled to the left, therefore the mean will be smaller than the median. Right? And if the data is being pulled to the right, then vice versa, the mean will be greater than the median. Right? Remember, the median is always going to be in the center. Right? The value of the median is unaffected by the extreme values. So the mean was the one that's going to be pulled. Right? One of the usefulness of this is that if you know the relative position of mean and median, then it gives you a pretty good idea if the distribution is skew left or if the distribution is skew right. Right? If all you know is that the mean is greater than the median, then you know that the distribution is skew right. Right? For example, we can look up average income versus median income. Right? Suppose that the average income in San Francisco is let's say $300,000, but the median income is $90,000. Right? Knowing that fact, then you can conclude, right, that there's a few high income earners that is pulling the average up. Now, speaking of extreme values, right, if there's extreme values present, there might be some situations where you might want to get rid of them. Right? Now, trimmed mean is one of the procedure that you can use to get rid of these extreme values. Right? The idea is very simple. You simply choose a percentage of the data that you would like to trim. Right? For example, a 5% trimmed mean, right, is you remove the bottom 5% and the top 5% of the data. Right? Let's do an example to see this. So first thing you want to do is count how many observations there are. So here we have 13 observations. Okay, next we want to do a 10% trim mean. So find the 10% of 13. Right? And 10% of 13 equals 1.3. Now we want to make sure that we trim at least 10%. Therefore, right, we need to round up to the next whole number. So we're going to trim two numbers from the bottom and from the top. Now, what if you get 1.1? Do you always round up? Well, that depends on your objective. If your goal is to trim 10% and at least 10%, right, then you should always round up, even if you calculate this to be 1.1. Okay? Because if you round down, then you are not trimming at least 10%. You are trimming less than 10%. Okay? The only time you need to be aware of this, or I should say, you should always be aware of this when you use a computer software, right? Because these are commands that you could type into, right? Excel or Google Sheets and other statistical softwares. And when you type in trend means, you want to be sure that the program is, or you know what the program is doing. Right? Now, unfortunately, there is not a universal, 100% universal agree upon procedure for this. Now, as far as I know, though, trend mean, if you put in 10% trend mean or any percentage, the procedure for at least right now for most of the software that I've used always rounded up. Okay. Now, so we're gonna get rid of 2. So you cross out these 2. Go to the top now. Cross out 2. And then we will simply take an average of whatever is left. Okay, so we just take that x bar, which is you add up all the x values and divide it by, now however many is left here, that is going to be 9. Okay, and if you did the calculation, go ahead and give it a try. You're going to get 20.667. Next, weighted mean. Right? Now, weighted mean is actually quite useful because there are going to be situations where right? Every observation, or I should say, you want to give a different importance, right, for each observation. Maybe, right, if you have additional information, right, regarding the observations that you want to include when you calculate the average, right? Let's look at this example, and I think that will become clear. So here is examples of construction projects, right? And here we have 5 different types of laborers, and each of them have this wage, right? And you would like to know what is the average cost, right? Or what is the average wage for each hour of work. Now this might be useful, right? For example, if you want to provide an estimate for a different project, right? And holding all else constant, if most projects are involve the same type of work, right? Then the average wage, right, of each worker, or each hour worked might be important to you. Okay. Now, however, right, for a given project, they work different hours. Right? Here's the total hours, and you can see that, for example, a carpenter works on this project many more hours than a plumber. Right? And then so then if you simply add up these wages and then divide it by 5, it will not be representative, or it will not be as accurate and useful. Right? So we would like to give these wages, each of these wages, right, their weight. Okay. Now, so with X bar, like first, this is a summation on top and bottom. Right, so let's go ahead and write this out and see what's going on. Okay. And it's always a good exercise to write out the summation notation, right, so that you know what this formula is trying to tell you to do. So I have each of the W's. That's going to be the weight. And I'm going to take the weight multiplied by the observation. So this is essentially weight 1 multiplied by x1. Weight 2 times x2 plus weight 3 times x3, and so on. Weight n times xn. And you divide the whole thing by weight 1 plus weight 2 plus plus weight n. You divide it by the sum of all the weight. All right. Now here I have two columns. This is going to be my x, and this is going to be my weight. Okay. How do I determine the two? Well, because I care about wages. I care about, on average, how much each hours of work cost. All right. So this is my focus here. All right. So now, since I have living columns, then it's really convenient. I can make a new column, and this will be my wage times xi. So weight times the wage, right? The weight here. So just multiply across. Right? Take 21.60 times 520, and so on. Okay, go ahead and give that a try. Pause the video if you like. Okay, hope you can see that clearly. Check your answer there. Sorry for the handwriting. I don't have much room here. But basically, I'm multiplying across, and this is each of the components in the numerator. Next, what I have to do is add them all up. So I simply add down. Okay, and this will give me my summation wi times xi, right, which in this case is equal to 31,873.70. Okay, now my formula requires that I sum up all the weight. So next thing I'm going to do is add up all the weight. Summation wi is going to equal 1590. Okay, that's all the combined weight of the observations. And then next I'll just have to do x bar equals 31873.7 divided by 1590. Okay, put that in. You should get $20.05. Okay, now notice that I have x bar and x bar. X bar, which is the same notation as the sample mean. Right? Now, the regular mean with the sample mean is really just a special case of the weighted mean. Okay, if you think about it, the sample mean, all the W's are just 1, right? If you replace every one of these with 1, then you will get the sample mean. So we can use the same notation. But if you like, you can also put a W here so that you can indicate that this is a weighted mean. Okay. All right. Geometric mean. Okay. So geometric mean right, is the nth root product of the n value. What does that what does that mean? So basically, right, I'll just give you the formula first. The geometric mean, we're going to just say x bar g. Okay, we don't have a special notation for geometric mean, so I'm going to use a subscript here. Geometric mean, mathematically, means this. If you have a set of x values, let's say x1, x2, and so on, xn, right, and you want to find the geometric mean of these numbers, then first you just multiply them all together. Next, you take the nth root. Okay, this is very similar to, say, right, if your regular average, right, you take x bar, you take x1 plus x2 plus x3 all the way to xn, and then you divide it by n. Right? This is called the arithmetic mean. Right? This is the one we all know and love. Right? A geometric mean, just instead of adding, you multiplying, and instead of dividing by n, you taking the nth root. Right? Conceptually, not that much more difficult. Like for example, if my xi's are, let's say 2, 7, and 3, I want to find the geometric mean, then all I have to do is take 2 times 7 times 3, and then I take the cube root of that. Right? Okay, so that means I take the cube root of 42, which, put it in your calculator, you should get 3.476. Now, for those of you who don't remember how to do the cube root, right, or any nth root, right, the nth root of x simply equals x raised to the 1 over n. Right? On your calculator, you should look for this symbol, right, the up arrow symbol. Okay, all right. Now, geometric mean are really useful for financial data, right? Because going from one period to the next, I'll just do a little graph here. You might have seen this in your finance class, right? Going from one to the next, you have a rate of return for each period, right? Okay. Some of you might have heard the term compound interest. Okay. Now, if I have, let's say that at the end of the 3 period, and I want to find out what, on average, what is my return, right? Let's say, for example here, right? If I have these returns, if I simply add them up, and then divide to find the average, it's not going to be accurate. The reason for that is because the interests are compounded, meaning at the beginning of every period, I'm not starting with my original principal. I am starting with my principal plus the interest from the period before. Okay, and so I need to take that into account. Okay, and because this is all being multiplied, right? I need to use geometric mean. All right, so I'll do an example here using this growth factor. Now, however, for you, because it's not a finance class, you do not need to know what growth factor is. I will never test you on what is growth factor. Any question that I ask you about the geometric mean will simply involve you taking a set of numbers and calculating geometric mean this way. But I want to present this to you because in practice, geometric mean is used mostly when you calculate growth rate in finance. All right, so here we go. So by the way, the growth factor is 1 plus r. That is the growth factor. So if you have a growth factor less than 1, that means you've lost money over that period of time. Okay, so I want to find the average growth rate. Therefore, I'm going to say x bar g. Okay, and what I'm going to do is just going to multiply all the growth factors together. Okay, so go ahead and just multiply them together. Multiply them all together, and then take the 5th root, because there's 5 numbers that I'm taking the geometric mean for. Okay, put that in the calculator. One more step, then you'll be taking the 5th root of 0.8925. Okay, the way you want to put that in the calculator is like this: 5 to the 1/5 power. If you did it correctly, you should get this: 0.9775. All right. Now, this is the average, or the geometric average, of the growth rate. Oh, sorry, growth factor. Okay, again, this step, right? I'm not even going to ask you this, just showing you this where it's used in finance. So to find the growth rate, we need to subtract 1. So it'll be 0.9775 minus 1, right? And that will give you negative 0.0225. What that means is, in this investment portfolio, on average, every period this individual is losing 2.25%. Okay, and that will be the end of handout 3.1.